Experiment number 1, measurement of resistance. Objectives: to find the resistance of an unknown resistor from the graph of the current against the potential difference across it. Safety: if too large current is used, then the wires can get hot, which causes burns. Apparatus: power supply, variable resistor, voltmeter, ammeter, connecting wires, 5 ohm resistor. Procedure: first, we connect the power supply to the electric current, switch on. Now we check the power supply, it is working, off. Adjust the power supply to 4 volt. We're starting the connection from the positive terminal of the power supply to ammeter, from ammeter to the resistor, from the resistor to variable resistor, but take care, in variable resistor we have 2 terminals. Fix the wire on this terminal and the other on the top. Connect the rheostat or the variable resistor to the other terminal of the power supply. We check our connection, switch on the power supply. Yes. Adjust the rheostat to minimum value of the current. We adjust the power supply, we adjust the variable resistor to the minimum value of the current, and then switch off. We connect the voltmeter in parallel connection to the resistor. This is parallel connection. We check the connection. Now we have to exchange the wires of the voltmeter because the needle go back to 0. Then just to exchange the connection. Now check again. Yes, it's perfect. Now the ammeter in positive side and the meter in positive side and the voltmeter in positive side. Now the reading of ammeter here depends on the scale. In the ammeter it is 0, 0.2, 0.4. So between 0 and 0.2 we have 10 dashes. So each one dash in the ammeter is 0.02. In the voltmeter 0, 0.5, 1. So the 1 unit has 10 dashes. So each dash is 0.05. Now we adjust the rheostat to the minimum power of the current. Now we adjust it to the minimum power. We start to take the reading. When you take the reading, to reduce the parallax error, you have to look normally to the ammeter and voltmeter. And one more thing, after you take the reading, immediately switch off the power supply. Why? To don't damage the resistor. Also, if the temperature of resistor increases, so the value will not be accurate. The temperature must be constant to verify Ohm's law. Now, we take the first reading of ammeter, switch on the power supply. Look at the ammeter normally with one eye and close the other one. Here it is 1, 2, 3. So it is 3.5 dashes. Again, one more. It is 3.5 dashes for ammeter. So 3.5 multiplied by 0.02 for the ammeter, the answer is 0.07. Take the corresponding value of voltmeter the same way, the same procedure. Look normally to the voltmeter with one eye, close the other eye. And here it is 6 dashes, 6.5 dashes. Here it is 6.5 dashes. For the voltmeter, 6.5 dashes multiply 0.05. So the reading of voltmeter is 0.325. Another reading of ammeter and voltmeter increase the current and voltage here. Then I adjust here. Now switch off. Take the reading of ammeter. Look normally to the ammeter here. It is 4.5 dashes. For the ammeter, it is 4.5 dash multiply 0.02. For the ammeter, it is 0.09. We find the corresponding value of the voltmeter here. So it is, again, look at the ammeter. So it is, okay, here. It is 9 dashes, 9 dashes. So 9 multiply 0.05, it is 0.45. Another reading for ammeter, increase the current here and voltage, of course. Now, here, the current is 6 dashes here, 6 dashes. So 6 multiply 0.02, so it is 0.12 ampere. Now we find the corresponding value of the voltmeter. It is 10 dashes for the voltmeter. 10 dashes multiply 0.05. So it is exactly 0.5. Now, take another reading. Now, switch off. On again. The current is 7 dashes. So the current is 7 dashes. 7 multiply 0.02. It is 0.14. The corresponding value of the voltmeter here, it is 12 dashes. So 12 multiply 0.05, it is 0.6. Another reading. Again, with one eye, it is 8 dashes for ammeter. 8 multiply 0.02, so it is 0.16. The corresponding value of the voltmeter, 15 dashes. 15 multiply 0.05, it is 0.75. That are the results in the table. Calculations and analysis. Plot the graph of voltage, y-axis, then we represent the voltage on y-axis versus current on x-axis and the current on x-axis. The current on x-axis, then we write here, this is 0.0, okay, 2, then, so this is 0.02, 0.04, 0.06, and so on. This is the current. What about the voltage? Because the voltage are very small, we can multiply the voltage here by 10 to the power negative 1. Voltage multiplied by 10 power negative 1. 1, 2, 3, 4, and so on. When the current is 0, of course the voltage will be 0. Then this is the first point, 0 and 0. The second point, so this is 0 0.7, 3.3. Now we draw the best fit line. A line passes through most of the points. Now this is the best fit line. What is the relation between V and Y? It's a direct relation, or it is linear relation. Use the plotted graph to determine the resistance of resistor. We find the slope. We find the slope from this triangle. The gradient equals y2 minus y1 over x2 minus x1. y2 is 6 minus y1 is 0, but remember in y-axis we multiply by 10 power negative 1. So multiply by 10 power negative 1 over x2. This point is 0.13, so 0.13 minus 0. We use the calculator to get the value. The answer is 4.6. Because it is VI graph, then the resistance R equal the gradient. Then the resistance is 4.6 ohms. Compare the calculated value of the resistance R. The calculated value is 4.6 ohm. To the actual value was 5 ohms. Now we can divide the big by the small to compare. We have to do division. So the actual value over the calculated value equals 5 over 4.6. 5 over 4.6, it is 1.1. Then the actual value is 1.1 times more than the calculated value. So the actual value is 1.1 more times than the calculated value. Value R. What are the sources of error? Number one, systematic error. In the circuit, we did not use switch. We depend on the switch of the power supply. So this is systematic error. Number two, random error. Random error for measuring the current and voltage. So sometimes we do not look normally, so this is called parallax error. We do not look normally to the reading of a meter or voltmeter, so this is a random error. Number three, the best fit line, because the value of the resistance depends on the graph, depends on the gradient of the graph. So the best fit line, maybe we did not draw the best fit line in correct way, or passing through the most of the points. So the best fit line is the third error of this experiment. Now the conclusion. In conclusion, in this experiment, we calculated the resistance 5 ohm from IV graph. It was 4.6 ohm. Our calculated value was 4.6 ohm. This value is near to the actual value. Also, we found that the potential difference is proportional to the current, as Ohm's law mentioned. Some values are extreme at the beginning, maybe the temperature affect to the values. Finally, the actual value is 1.1 times more than calculated value. No very far away, so the result is acceptable significantly. I hope you understand this experiment. Thank you.